Our next transformation is called a rotation, and it is just like it sounds. It's when we turn or spin a figure around a specific point. But if we want to rotate a figure in the coordinate plane, we'll probably want to understand a couple of other things too. So let's look at that first. All right, so let's talk about rotations a little bit. A rotation is a transformation in which a figure is turned about a fixed point, so a point that isn't moving. For us in this unit, we'll be mainly rotating about the origin. So that fixed point is called the center of rotation. So in rotating figure, we are just spinning it around a certain point called the center of rotation. If you draw rays from the center of rotation to a point and its image, you form the angle of rotation. So that angle of rotation is just how much did you move it, right? At what angle did it move? We'll be working with three specific degrees or angles: 90, 180, and 270 degrees. Something else that might be helpful to know is when we talk about degrees or rotations, we're talking about moving in a circle, right? So if we're talking about moving at a 90 degrees, you can think of a circle. So let's say I start here, and we say this is 0 degrees, because this is where we start, right? It's completely flat. There is no angle. But if I move it up a quarter of that circle, that's 90 degrees, right? You see how it's forming a 90-degree angle. Or if I moved it another quarter around the circle, that would be 180 degrees, right? Because that's 290 degrees, or it's a straight angle, like we've talked about before. Or if I move it another quarter, okay, that would be 270 degrees, another 90 degrees, okay? See how there's 4 90-degree angles here, okay? But also, what does this look like? It looks like the coordinate plane, right? Here's my x-axis and here's my y-axis. So when we move in the coordinate plane, and we say we're moving 90 degrees, here we're moving 1/4, okay, or 1/4 of that coordinate plane. It will also be helpful to know the names of the quadrants that we're in. So if you remember this from middle school, when you're looking at the coordinate plane, the first quadrant is right here, the second quadrant's right here, the third quadrant's right here, and the fourth is right here. Okay? Starts in the top left and then goes counterclockwise, 1, 2, 3, 4. All right, so let's look at some examples of rotating these figures. So we're going to rotate each of these points counterclockwise. Okay, notice that it says counterclockwise about the origin by the given angle, and we'll state the coordinates for that image. Okay, so the first one, A, we're told is at 6, 0. So that's right here. Okay? That's right on the x-axis. And we're going to rotate it 180 degrees. So just like in our circle, okay, if I'm rotating it 90 degrees, I would rotate it here, and then if I rotate it 180, I would rotate it again to right there. And it's going to stay in that same position, right? Because it's just rotating around that circle, right? It's not going to end up, it's not going to end up right in here, right? I'm rotating around a circle. Oops, be more accurate there, like that. Okay? So if I rotate this 180 degrees, that point would be here. So here's A, and here's A prime. And that would be rotating that point around the circle 180 degrees. So A prime is at the point -6, 0. Okay. For B, B is at -2, 6. It's right here. And I'm rotating that counterclockwise 180 degrees. So if you notice, this one isn't on the axis, but if I know I'm going 180 degrees, that's 2 quarters, okay? 1 quarter and then another quarter. And instead of quarters, you can also think about it as quadrants. So I'll do this one into quadrant 1, and then into quadrant 2. Or I started in quadrant 2, so I'm going to quadrant 3 and then quadrant 4. Okay? That would be 180 degrees. And again, it should form a straight line, right? So it's going to be somewhere in here because that's 180 degrees. So if we rotate this 90 degrees and then 180 degrees, we would get to -6. Because if we're still rotating, it's here and then here. Rotated like that. And that would be B prime. Oops, I put prime up there, didn't I? That would just be B. So B prime is at 2, -6. Okay? And you can see how that's 180 degrees right there. So instead of -2, +6, if I rotate 180 degrees, it's 2, -6. Our last one here is C, is at 0, 3. 0, 3, that's right here. That's C. And I'm going to rotate it 90 degrees, so I'm only going to go 1/4, okay, or into one other quadrant for C prime. So if I rotate it 1/4 this way around the circle, that would be right here. There's C prime. Okay? And so that's rotating each of those points. Rotating each of those points, with the given degree. And so C prime is at -3, 0. Let's just do one more. We're going to skip a couple of these. Let's just do one more. We'll do number 5 here. E is at -4, 0, 270 degrees. So same instructions. Rotate the point counterclockwise about the origin by the given angle. And we'll state the coordinates for that. So E is at -4, 0. That's right here. And I'm going to rotate it 270 degrees. And so if you remember, that is 3 quarters around the circle. So I would go first here, that's 90, and then 80, and then 270 is right there. I was at 4, right? 90, 180, 270. Okay? So it's up there. So you move 3 quarters or into 3 different quadrants. And so E prime would be right here at 0, 4. Okay? So again, it's important to recognize that when I move 90 degrees, that's just moving 1 quadrant over, 180 is 2 quadrants over, and 270 is 3 quadrants over. 360 would be all the way around, right, because that's a full circle. And so rotating that 360 would just be getting back to where you started. If you're paying real close attention to the points of the pre-image and the image in those examples, then you may have started to notice a pattern. Well, these patterns that we notice help us develop rules for the coordinates of a figure that's being rotated in the coordinate plane. We'll look at these rules now. And you'll note that these rules are specifically for figures that are being rotated about the origin. So it might be hard to always visualize the circle and how much you're rotating with those points, and especially if you don't have the tools to necessarily measure everything out. And so there are certain rules that we can learn for rotating figure or rotating any figure or point about the origin. So we have some coordinate rules that will help us do that and makes it a little simpler. So if you have this point AB and you rotate it counterclockwise about the origin, each of the following are true. If we rotate that point AB 90 degrees, that point is -BA. That rotated point is -BA. And so the coordinates flip, and the first coordinate will change signs. Okay? Or really what becomes the first coordinate, the original second coordinate, is that B. Okay? So you can see here, starting at, over in the figure, if you start at AB and you rotate it 90 degrees, it's over here to be -BA. And so whatever values those are, you can flip them and you make that what is now your first number, the opposite sign. If you rotate 180 degrees, you keep them in the same position, but they both change signs. And then if you rotate 270 degrees, they switch positions, and then now the second number changes signs. So that's what's going on in this figure here. We're seeing as it rotates how that's changing the point. And that's it's because you're changing quadrants, right? So that's the pattern that we notice. Like as we go into the different quadrants, the 1, 2, 3, and 4 quadrants of the coordinate plane, we see the point values change. Or not the values, but the signs and their position. Right, those are rules that we can use to help us rotate these points about the origin a little bit quicker than having to actually look at, okay, where is it moving in the coordinate plane. So let's look at a couple examples of that. Number 7, it says graph the triangle JKL with vertices 1, 3, K4, 3, and L4, 1. And we're going to graph that triangle and its image after 90 degrees counterclockwise rotation about the origin. Okay, so let's first graph that triangle. J is at 1, 3. K is at 4, 3. And L is at 4, 1. And so we're going to rotate this figure about the origin 90 degrees. And now you could, with each of those points, just look where is that going to be rotated, how is that going to move around a 90-degree angle. But it probably will be easier to rotate it using the rules, the coordinate rules that we just looked at. So if J is at 1, 3, and we're rotating 90 degrees, so the rule is that the coordinate values switch and then you change the sign of your first number. So J prime would be at -3, 1. Okay? So notice how I switch the coordinates and then the first one changes sign. Let me use a different color. K is at 4, 3. And I'm still rotating 90 degrees, so it'd be the same rule. This would be -3, 4. And L is at 4, 1. So L prime would be a -1, 4. Okay? So again, just using my 90-degree rule. Okay? So you want to keep that in mind or have that in front of you. Okay? I'm just switching the order of the values and then changing the sign of that first number. And so I can then graph those points, and that would be my rotated figure. -3, 1, -3, 4, -1, 4. There's J prime, K prime, and L prime. And so there, this triangle has been rotated 90 degrees. That's what the rotation would look like. Okay? Again, those can be kind of hard to visualize sometimes, so that's why you really want to understand the rules to make sure that you're rotating it in the right way.